Hello everyone. If you have stumbled across this video for the first time and did not watch my micro lecture series, first of all, I'm sorry, you've missed out on a lot. No, I'm just kidding, it's fine. Just, come and go as you please, pick whatever videos you want and watch them, and I certainly hope that they are a blessing to you. The only thing that I do ask is that you go to my website right down here, joeyjohnsondo.com. It's joeyjohnsondo.com. Go to the donate tabs, and if you will, by all means, please donate $3. I'm asking for a one-time only $3 donation fee, please. I certainly appreciate that. Thank you. Today we're going to talk about a very simple yet high yield yet complex topic, okay? And I'm talking about sensitivity versus specificity and negative predictive value versus positive predictive value, all right? If you are taking a COMLEX or USMLE, there is a high likelihood that you will get asked a question about this. I mean, I am willing to bet you will get a question on this subject. Don't let them get you out, okay? Let this be something that you see, you understand, and spend a little bit of time on and move on, okay? So let's go over this right quick. Specificity is helping you to rule in anything that is a true positive for what you're testing. Sensitivity is helping you to rule out, okay? Helping you to rule out things, okay? Once again, specificity, we are ruling in true positives, okay? And so if you get a true positive in a very specific test, you should have a lot of confidence that that which tested positive is absolutely a true positive, okay? And so let's go ahead. I've got an example here. 15 people, okay, are getting tested for diabetes. 7 of them will have it, 8 do not have it, okay? And so here are their diabetic numbers right here. So as you can see, the ones that definitely have it are going to be this column right here. This is their blood sugar level, okay? And these right here still have diabetes, but it's not as high as that one, okay? Now, the actual number that we're looking for on this test is basically if they test 135. Now, this is all hypothetical, okay? This is so you can understand all of this stuff. 135 is what I'm saying is the limit. If they are over 135, then they are truly diabetic. That is the cutoff number right there for being diabetic or hyperglycemic diabetic right here, okay? And so, we're going to have all these that are going to fall short of that, okay? None of these are going to be true diabetics. None of these are. This one is, and all of these are going to be true diabetics for the purposes of this, okay? So if 135 is the actual limit, if we set the limit to 126, okay, then 10 will test positive, because based on these right here, 126, right, this whole column right here, everyone in this column and everyone in this column are over 126, right? So if all of them in both columns are over 126, then that means all of them are going to test positive for this very sensitive test. So what we end up doing is we get all 7 of the true positives, okay? So those 7 true positives are, all of these plus these 2 over here. And we end up getting 3 false positives because with us setting the bar so low, these 3 that are 128 right here tested in for it as well, and those are false positives, okay? So this test is going to have a high negative predictive value, okay? It also it got 5 true negatives. Yes, all 5 of these are truly negative, so I did get that. But this has a high negative predictive value, okay? And we'll talk about that more in a little bit. I like to talk in terms of positive stuff. So for specificity, we set the bar very high. We set 140, right? So there are 5 of them that test over 140, but what about these 2? Remember, we said 135 is the actual true number for being diabetic for these purposes. So you've left those 2 out, right? Because you set your bar here to be 140, highly specific. What does that mean? Well, since 135 is the actual limit, anyone who tests over 140 is 100% going to be diabetic, right? So what you end up with in this scenario is you get 5 true positives. Those people are absolutely, unequivocally diabetic. These 5 right here, they are absolutely diabetic. But you have left out these 2, my brother or my sister, right? Okay, so you've got 2 false negatives. You have counted 2 people out as being negative, and they are not negative, okay? But you have a very high predictive value. And so what that means is if I come up to you and say, I want a test to absolutely unequivocally say my patients are diabetic, you might give me this test right here, 140, and say 100% if they test positive on this test, they are diabetic. Alright, feel like Maury Povich here. You are diabetic. Anyhow, so notice now the negative values, right? So right over here, this very sensitive test has 5 true negatives, whereas the very specific test is saying that there are 8 true negatives, right? Okay? Now all these are going to end up to 15 as you see, right? And so what accounts for the difference right there for the true negatives? Well, if you notice, this one counted some false positives. They weren't really positive, but it counted it in. This test was sensitive. It's like, oh man, yeah, you look like you might be diabetic. Come on over here. Oh yeah, you don't really fit for diabetes, but yeah, you're fine. Get yourself over here. We're calling you diabetic so you can be in my group. It is sensitive. It just congregates everyone, okay? And so in doing that, it gets overzealous, and it definitely gets some false positives up in there, right? All right, and so your true negatives number drops. It can't really distinguish what's a true negative because it's too busy trying to include people, right? Rather than get people out of the group. Now, whereas over here, a very specific test, they are too busy trying to actually get people out of the group, and trying to only rule in the true positives. That's where the spin comes in. Specific to only rule in the true positives. That is absolutely it. It wants to only rule in the true positive, okay? Now, SNOUT, the reason why sensitivity is going to rule out is because it is going to be so all-inclusive, right, that it is going to rule out basically the possibility of the group that, basically, the groups that do not fall within its inclusion are absolutely unequivocally going to be ruled out for having that disease you're testing for. So in this case, it only ruled out 5 people, but those 5 people absolutely unequivocally do not have diabetes. Whereas this one tried to rule in only a specific group of people, so those people it ruled in was absolutely unequivocally going to have diabetes, okay? So that's where the spin and SNOUT comes from. Now, when we look at these tests, okay, let's drop our standards a little bit to 135 and see what happens, okay? Since that's the actual limit, now what happens here is you still have a high predictive positive value, but it's less than the 140. In other words, if you gave the test for 140 right over here, right, those people absolutely will have diabetes. Now over here, these people at 135 are, we know that 135 is the actual limit, so we know they absolutely have diabetes. But my point is, it's not 100% as if the 140 was. Okay, some of these folks could test positive because, let's say, they have some sort of infection that raises their blood sugar and you tested them during that time, or they took a certain medication, right? So 135 is not as certain as 140 is for them absolutely having diabetes. So now let's go over here. What if you combine or compare these two specifics, right? And so that's my point. Everything was fine and dandy here. Yeah, high predictive positive value, but when you compare these two, all I'm showing here is just making a point that absolutely, if you set the bar higher, then they have a much higher positive predictive value, okay? And look at here, this absolutely high positive predictive value is so high and so exclusive in including people, it is so VIP that it says even people who are diabetic might get counted as a negative and not being included in the in crowd, right? Everybody wants to be in this diabetes crowd. He's only letting certain people in. Nope, he didn't count you in. But you were really a positive, but he's saying that you were negative because his standards are so high, so therefore these two people that actually were 138 and truly were diabetes, since 135 is our actual number, they actually got included as a false negative. They weren't really negative, but they were counted as a false negative. Whereas when we dropped our standards a little bit, our predictive positive value wasn't unequivocal as this 140 limit, but it did pick up those folks that were, that were actually true diabetics and kind of on borderline there. So let's look at this example. Let's say you want the highest bouncing ping pong balls, right? So here's a ping pong ball right here, right, and it goes up, bounces 2.5 feet, okay, right there. So we're going to say 2 feet of bounce, and it's like, those are horrible balls. Those don't bounce that well. 3 feet, that's average, but I want the best bouncing ping pong balls, right? So let's say my wife sells the absolute best bouncing ping pong balls, or she says she does, right? And she sets her standards as, she says, unless they bounce, my wife's name is Jessica, so I'll write that right here. Unless they bounce 5 feet in the air, then they don't count for me. I will not sell them. And I'm like, shoot, I want to make that money, honey. So I'm going to set my limit at, let's say 4 feet, okay? At 4 feet, I'm going to say, hey, it's above average, right? So, should still work, right? So my wife's selling 5-foot bouncing balls. I'm selling 4-foot bouncing balls, okay? And so you come over and you look at it and you say, well, 3 foot's the average. Yeah, Joey's got some good balls because they go up 4 feet, but, I don't know that they're absolutely the best. Now, will some of my balls bounce 5 feet in the air? Yeah, definitely, because my standard's 4 foot. Some of them could bounce 20 feet in the air. That'll still count as being to my standards. My standard is 4 foot. So I'm going to get some that are going to bounce 4.1 foot. I'm going to get some that bounce 20 foot. You don't really know what you're getting, but you do know that it's better than average, right? So, that's what you got. So my test is more sensitive in the sense that it's more inclusive. I say, hey, if you're over 4 foot, you're good enough for me to put on the shelf. That's my balls, baby. Give them to me. I'm going to put them on the shelf and sell them. Now, my wife says, they have to be 5 foot. I have a higher standard. So she is more specific on what balls she lets come in. Okay? So she says, only 5-foot bouncing balls are what I am going to put on my shelf to sell, baby. So that 4-foot junk, get that out of here. It's 5 foot or over, right? And so you're going to come in, you're going to say, hey, I really like her style. I like what she does because that's what I'm looking for, the best bouncing balls in the county. Joey, you are out, because she's going to include the 20-foot bouncing balls and the 18-foot bouncing balls as well, but the lowest you're going to get for her is 5 foot, whereas the lowest you might get for me is 4 foot. I shortchange you. Okay? Now, how does this have a practicality to it? Okay, let's say that somebody over here has Ebola where I live, right? So we're going to want the most sensitive test possible because that is a very dangerous disease. We want to rule in as many people as we can initially just to make sure that the people we say do not have Ebola can absolutely, unequivocally be ruled out from having Ebola, and they can go out into the world and do whatever the heck they want, and we don't have to worry about another situation like that one nurse, right? To where everybody's like, oh my gosh, she might still be contagious. Now, if somebody has common cold, we only want to rule in to take care and hospitalize folks that really are severely damaged. Like, let's say that I set my bar so high, I say, man, I only want folks that are immunocompromised, folks that have, absolute AIDS infection, folks that are having renal issues or something of that nature, or hepatic issues along with their cold. So I'm only going to rule in people that absolutely need my help to be hospitalized that have a common cold. I don't want just a snotty-nosed kid running around that's probably going to infect his parents, have them out of school and work for over 2 weeks while he's running around playing kickball outside, and the parents are like, I thought you said you were sick. And he's like, oh, I feel better now, give me ice cream, right? So for something that is a very common situation, you want the most specific test possible. For something that is a very dangerous situation, you want the most sensitive. Another example of this, you give TB skin test. There's a lot of stuff that can make you have a false positive for that, so therefore it is a very sensitive test initially. Okay, then you take them and you give them a chest x-ray, and you get very specific because you're looking for specific things on the chest x-ray. So you ruled in a lot of people initially just to be safe, so that the people you say are ruled out are absolutely able to be ruled out and walk around in the world and not worry about you getting folks, infected and having a lawsuit on your hands later. But then you're going to get it more specific, right? So that the people you're actually going to put through the rigorous treatment are absolutely unequivocally specific and specified to have AIDS. I mean, not AIDS, but tuberculosis, right? This is a chart right here. On the next lecture, I will go through some of these calculations just because this is such a high yield topic, people. So let's end it there. When we come back, I'm going to do the calculations with this to show you how to work this chart right here in all of its glory and all of its magic. And by all means, people, JoeyJohnsonDO.com. Go there. Donate your $3 if you have not yet. Thank you so much. Talk to you next lecture.